All right. Today's lesson, 6.4, is on the area between curves as well as what's the average value of a function. So, let's look at the beginning here. Do you recognize that integration from a to b f of x dx? That's a definite integral that connects us to the fundamental theorem of calculus, and it produces what's called signed area. What does that mean? Area above the x-axis is positive. The area below the x-axis is negative. So it might be positive, it might be negative, it might even be 0 if what's above matches what's below, so they cancel each other out. However, if you're asked to find an actual area, the area cannot be negative. So, the area of a region is described here. So, I want to make sure you understand how it's connected to what we did. So if I look at that, what you need to take from this is this. That when you see the two graphs, you have to recognize which curve is on top and which curve is on the bottom, because then when you calculate, the area will always be positive if you go top, subtract, bottom. That might be trickier than you think. It's not trickier here, right? F at x is on top and g at x is on the bottom, but if you're given equations and not a picture and you have to do the graphing, that might be a challenge to know which one's on top and which one's on the bottom. But that's part of practicing. So, why would that give me the area in between if I go top, subtract, bottom? I want you to think this through. If I integrated just the top, it's the area of that going down to what axis? From here to where? Right? If I just did the top, right? If I just did the bottom, it's the area here, from that curve down to the x-axis. Does it make sense to you that when you subtract those two answers, that what's left over is the area in between? So from the axes up, when you subtract, what's left over is the area in between. All right.
Why is it two curves?
Why is it 2 compared to what? 3 or 4 or 5 or 1 only?
Yeah.
So if it was 1 only, it would be the x-axis to that curve. For 2, you're looking for the area trapped between the two. So if you go from the x-axis up and the x-axis up and then subtract the two answers, what's left over is what's in between. So we're learning how to find the area that's trapped between two functions. How do I do that? Is I integrate. And it's top, subtract, bottom. That's the big picture. So what's the big picture again? To find the area between two curves, you do what? Integrate. And it's top, subtract, bottom. And your bounds are going to go right to left. So your bounds are x values in terms of that. So your upper bound would actually be the bigger x value, and your lower bound, right, would be your left x value. So for functions of x, it's top minus bottom. If it wasn't in terms of x, if it was in terms of y, it would actually go left to right. It would actually not be top, subtract, bottom, but right, subtract, left. And your bounds would actually be upper and lower in terms of that. But we need to practice. So example number 1. Find the area of the region bounded between y equals x squared plus 2, y equals x equals 0, and x equals 1. So let's make sure we understand what each one is describing. So for y equals x squared, is that the top curve or the bottom? Good. For y equals x, can you identify it? How about x equals 0? What does that describe? Well, do you know it's a vertical line that goes over 0? And x equals 1 is a vertical line that goes over what? And again, those give you your bounds. So I need you to set up the integral. So you're setting up an integration, top subtract bottom. So the first step is, can you set up the integration? What function's on top? X squared plus 2. What function's on the bottom?
X.
Can you subtract the 2? So this is what it would look like. The bounds go from what number to what number? 1 to, the upper's up there, the lower's down there. So from 1 to 0. And inside would be x squared plus 2. And it's good practice, even if you don't always need it, to use parentheses, because when you're subtracting, that subtract sign can make signs change, right? When you use parentheses, you're more accurate to know what the signs would be. So even though there's only one term, let's say there was a binomial or a trinomial, that subtract sign would distribute to both after it. So we have x squared plus 2, we have x, and that's what we're integrating. All right, I need you to simplify it. Can you actually do that work without a calculator?
Of course, yeah.
Go for it. So without parentheses, it would be x squared plus, if we put them in order, it would be x squared minus x plus 2. So I want you to integrate. And then I want you to use your calculator to see if you did it right. And if I'm not able to finish the whole lesson before the bell rings, I'll just do another video during my prep period. We'll go from there. So there's about 15 minutes, so we'll see if we can finish it or not. Okay, so how do I integrate a definite integral? So what do I do with the exponent, x squared? It becomes x cubed, and then divide by 3. Negative x. What exponent don't you see? So you add 1 to 1, and it's now x squared, and divide by 2. And then 2 by itself is just what? 2x. And we're integrating from what to what? 0 to 1. What number do you plug in first?
1.
Good. So plug in 1, and that becomes what number? 1/3. Plug in 1 to the next one, and it becomes 1/2. Plug in 1 again, and it is 2. That's just plugging in 1. And then we subtract and plug in what? Well, what answer does 0 give you in this case? 0. All right, simplify that to one number. 1/3 subtract 1/2 plus 2 without a calculator. Do you know what 1/3 subtract 1/2 is? No. To subtract fractions, you need common denominators. What would be the common denominator? So top and bottom times 2. Top and bottom times 3. This one would actually be top and bottom times 6, right? So put it together. So the answer is going to be 6. It's 1. Sorry, 1. It's 2 subtract 3 plus 12. So what answer do you get? Okay, take out your calculator if you have it. Okay, I want you, we're going to do this by graphing. So, I want you to get to the graph. What we're going to type in is x squared where is it? Oh, I lost it. Plus 2 minus x. Sure you can. X squared minus x plus 2. I want you to notice that when you subtract and put them together, what do you notice? Is that together they make a parabola, right? Now, how do I integrate using my graph? I just want to show you something else you can do with your calculator. If you press menu, what would you think you would go to? Analyze, graph, and then what would you go to? Yay, I see that, right? Oh, there's even a bounded area one. Let's do the integration, and then maybe we'll try the bounded one later. But right now we already set it up where we can just integrate. And what's the lower bound? At what number? 0. And then what's the upper bound? And then what answer did you get? 1.833. What do you think 11 divided by 6 is?
2.83.
Yeah, it's the same thing, right? Now, that's when we already put it together. The calculator actually allows us to graph both of them at the same time and then find the area bounded by the two, but we'll try that later. But here's a way that you, with the graph, that you can get the answer for the integration. All right, let's go back and look at example number 2. Says sometimes you have to find where two curves intersect to determine the boundaries for your region. These intersections will provide you with limits of integration for your integrals. You must show an equation setup even when using a calculator to find the intersection, so you get full points. So it says here, look at example 2. Find the area of the region. X equals y squared minus 3. And y equals x plus 1. Which one do you think you can graph first? Let's do that one, right? The first one is a little uncomfortable right now. So y equals x plus 1 starts at what? And what slope is it? Up 1 and then we're going to draw a line. Notice it doesn't tell us the bounds yet. And the reason it doesn't tell us the bounds is because the second graph is going to intersect it where the bounds will be those intersections. Do you know how to graph x equals y squared subtract 3? All right. Do you know what that picture would look like? The y squared gives you a sense that the square, that it's a parabola, but it's not a parabola that folds up or down, but sideways. What would happen if I asked you to solve for y? What would it equal? So to solve for y here, you would first add 3, and then what would you do? Is that right? But because you're solving a quadratic, one is positive and one is negative. Could you graph that, the square root of x plus 3? Where would be a great x value to start with for this? Why is negative 3 awesome? Because negative 3 plus 3 is 0, right? And that we actually can't plug in a number smaller than negative 3 because then it would be imaginary. So what's the smallest x value I could plug in here? Negative 3. If I went less than negative 3, it would be imaginary. So negative 3 plus 3 is 0, and the square root of 0 is what? So do we have a point? What shape again is this going to be? Upper and lower, right? It's going to be a parabola. So the top will be the top half of the parabola, and the negative will be the bottom half. What would be another nice number to plug in for x?
1.
Positive 1. Why positive 1?
3 is 4, 4 is 2.
So 1 and 2. I really like that point. Why do I like that point? Because they share. The line and the parabola share that, right? Can you draw the top half of parabola that goes through those 2 points? So I first plugged in negative 3. What's another number you could have plugged in that gave you a nice answer for a square root? Negative 2 would have given you what answer? 1. That's also a nice one. Well, guess what? The bottom half is going to reflect down, right, in terms of what that is. So you know what the bottom half is going to look like. But we know the numbers to plug in, just the y values are going to be negative. So I just told you, if you plugged in negative 2 to the bottom one, the answer would be negative 1. That's a nice point. Why is that a nice point? Because it's on the line, right? And then if you plugged in, what is the other one plugged in? 1. The answer would be negative 2 because of the negative outside. All right, do you see the sideways parabola? Okay, what's the area trapped between the two? Shade it. All right, how are we going to find the area trapped between the two curves? We are going to do what? Integrate. Can you tell me what the upper and lower bounds are? And recognize it's in terms of y. That means the y values are the bounds. What's the upper y value? And what's the lower y value? And it's down here, right? This one, I circled it to fool you. What's the lower y value?
Got him.
I got you. So the upper y value is 2, and the lowest y value in the bound is negative 1. So that's where we're going, from negative 1 to 2. When it's sideways, it's not top subtract bottom, but right subtract left. Which one's on the right? Which is what? Remember what I told you to write it in terms of parentheses? What's on the left? And why did I say, oh, geez, I did something wrong. You know what I did wrong? This needs to be in terms of y and not x, because our bounds are with what letter? Y. So this needs to be y. Is it easy to tell me what x equals here? So y equals x plus 1 means the same as, what does x equal? Y subtract 1. So don't make that mistake.
We can do it in terms of x.
Because this function, when I tried to solve for y, became complicated because we had a positive and a negative. There are some cases you could do either direction. Top, bottom, left, or right. This one is obviously easier to keep the 1 in terms of y than to have a positive and a negative. But this should be y minus 1, right, from here? And then that's the right side. What's the left? No, just keep it in terms of y. What is it? Y squared minus 3, and that's not dx now, that's now dy. Right subtract left. So we'll finish this, and then during my prep, I'm going to do the rest of the lesson, okay? We're not done yet, not done yet. I said we're going to finish this question. And then I'll do the rest during my prep. All right, can we do some basic algebra first and then integrate? So what would this look like if you simplified it? I'm going to go negative y squared, right? Plus y. And then negative 1 subtract negative 3. Plus 2. And again, it's not dx, but dy. All right, integrate that. That would be negative y cubed divided by 3. That would be y squared divided by 2. And that would be 2y. Go ahead. Do you know who you're looking for?
I'm looking for Johara.
Okay, she's over here.
Sorry, did I see that right? Okay. Sorry, I'm just rushing here. I come in there.
Okay, and we're going to integrate from -1 to +2. So what number am I going to plug in first?
2.
2, get an answer, right? Then I'm going to plug in -1, get an answer, and then I'm going to subtract the 2. I know. Show me the setup, and I won't make you do the headache. Make sure you put brackets around the first bound, subtract, and then another bracket for the second bound, where then I plug in -1.
But if you use brackets and just bigger parentheses.
What's that?
Or if you don't use brackets but just bigger
I guess. But that's why we have brackets, to differentiate. And you'll just believe me that the answer is 9/2. What we need to know is if you're allowed to use a calculator, could you find the points of intersection using your calculator? Could you set up the integration properly and get the answer 9/2 with your calculator? So when you do your homework, do it by hand as best you can, and then practice with your calculator, okay? And then I'll see you on Tuesday, Lord willing. Mr. G Math, 7202, over now.